is that of balancing. When we take our test, we'll have 10 equations in which we'll balance. If some of them prove difficult, I highly recommend the T-chart. Some of them you might just be able to count in your head. I'm going to work these through. If you prefer, pause the video, balance these equations, and turn it back on to simply check. If you want to work them with me, now would be a good time to do that with a practice T-chart. I notice the pattern of number 1, and we're balancing, is called a combustion. A hydrocarbon reacting with oxygen forms carbon dioxide and water. When we learn about a combustion pattern, the trick that I will show you is always balance the C's, then the H's, then the O's. The best strategy, C's, then H's, leave the O's for last. Let's tally. 1 carbon, 4 H's, and 2 O's on the left. 1 carbon, 2 H's, and a total of 3 oxygens on the right. The carbons look good, so we turn our attention to hydrogens. We need to double the product side. By doubling the product, let's repair the T-chart. 4 H's and 2 plus 2 is 4 O's. The carbons work. The hydrogens work. We need to turn our attention to the oxygens. 4 on the right, 2 on the left. Repair the T-chart, and we're there. A 1:2:1:2 mole ratio. Combustion patterns, C's, then H's, then O's. Number 2, we have an ion of sodium combining with an ion of chloride, forming sodium chloride. There's no trick here. This equation already is balanced. Sodium ion plus chloride ion combine. Pattern here, combination. They hooked by charge. A +1 electrically balances a -1. You're all set. Number 3, also a combination pattern. Elemental aluminum combines with elemental oxygen to form a compound based on charge, Al2O3. Tally left and right. We're counting aluminums and oxygens. There's 1 aluminum on the left, 2 on the right. 2 aluminum on the right, 3 on the left. 3 on the right for oxygens. I notice that if I start repairing the aluminum, I'm going to end up changing for the oxygen, because I just noticed right away I've got an odd number and even number on the oxygens. And always the trick to get that to work is to double the odd number. If I double the odd number, let's repair the T-chart. I now have 4 aluminums and 6 oxygens. So now I can see I need to repair the aluminums, and to get 6 oxygens, we'll need a 3. 4, 3, 2 balances that equation. N2 plus H2 makes NH3. I got to tell you, this does not belong, but it's not going to change the balancing. Elemental nitrogen combines with elemental hydrogen to form a molecule. Common household name here is ammonia. Ammonia, NH3. You might be familiar with its polyatomic ion, ammonium. Ammonia is the neutral molecule. Just a little nomenclature twist. Easy enough to balance. We have N's and H's to tally. Left, right, here we go. 2 N's, 2 H's on the left, 1 N, 3 H's on the right. Remember that odd number trick? Double the odd number. Let's double the odd number of hydrogens, repair the T-chart. 2 N's, 6 H's. The N's are working. Turning the hydrogen into a 6, we end up with a 1, 3, 2. carbon monoxide and hydrogen forming octane, an organic molecule, and water. Let's tally. We have C's, H's, and O's. Remember my hint? I like to go through C's and H's and O's in that order. Things just start to behave better when I have C's and H's and O's all in this kind of organic hydrocarbon chemistry. Let's tally C's and H's and O's. 1 carbon, 1 oxygen, 2 H's. 8 carbons, 18 and 2 more is 20, and an oxygen. All right, let's begin. We'll start at the top as I usually do with the carbons. We'll place an 8 in front of CO. Repair your T-chart. Now there are indeed 8 carbons and 8 oxygens. Carbons look good. Let's move to the hydrogens. We have a total of 20 on the right. We have a total of 2 on the left. Let's try a 10. When we put that 10 there, we now have 20 hydrogens. We're going to see something happen, but that's okay. When I come up here, 10 hydrogens, balanced. 10 times 2 is 20. In addition here. And that gives us these oxygens. Remember over here when we added the 8 and we changed the oxygens? That's really going to make this a little bit different, isn't it? We got to repair that. That's okay because we're always, the pattern is C's, then H's, then O's. Trust me, I've been around a while. That works best, even if it makes us go back and erase something, which this is about to. But the general pattern of C's, H, and O's pays off in dividends. But I do need to repair the oxygen, so let's repair the T-chart. I had to add 8 in front of the water to get the oxygens to move, but now let's count those hydrogens, because that indeed changed the hydrogens. 8 times 2 is 16, plus the 18 that was in that original hydrocarbon. That's 14, carry the 1. That's 34 total hydrogens. And that's okay. That means we just have to back up and repair the hydrogens. What do I multiply by 2 to get to 34? And we see that's 17. 17 times 2 can match the 34 oxygens on both sides. Still to this day, 25 years in, there are times where I end up crossing something off. That's okay. Keep the T-chart going and it will work. Number 6, FeO3 plus CO makes Fe and CO2. T-charts. I have Fe, O's, and C's we're counting. Fe, I count 1. Oxygen, I see a combined number of 4. And a carbon, I see 1. On the right side, 1 atom of iron, 1 carbon, and I have 2 O's. Irons look good, so we turn our attention to the oxygens. You'll see me, I'm going to grab a pencil. To double the oxygens, I'm going to start by placing a 2 in front of the CO2. Let's repair the T-chart. Not only did I repair the oxygens, there's 1, 2, 3, 4, but now I've also altered the carbons. Repair the T-chart. Irons look good. Oxygens look good. The carbons. Well, here's one of those situations now where I go back to repair the carbon. I'm going to alter the oxygen. You saw me grab a pencil. I knew this was going to happen. But always start with the T-chart. Start at the top, work the way down. And let's model what's happening. I repair the carbon, place a 2, repair your T-chart. But now all of a sudden I get 1, 2, 3, 4, 5 oxygen. Remember I've said when this happens, when I get an element repaired and it affects the other, so I repair that and I back up here, I find myself in this vicious loop. Here's the trick. It will work. What's the next biggest number from 2? The next biggest number is a 3. Try it. Great things happen. And we didn't know that till we got started, so don't be discouraged. FeOC. I'm just replacing my T-chart to what it originally was and starting over. I tried a 2 there and found myself in a vicious circle. The trick? Go up to the one next biggest number, a 3. Repair your T-chart. 3 carbons, 6 oxygens. Iron still are good. But now look. To repair the carbons, I place a 3. Combined total oxygen, 3 plus 3 is 6. A 1:3:1:3 mole ratio. When you find the number that you were playing with in the original number there, gave you this continuous loop, try the next biggest number. Number 7. H2SO4 with lead 4 hydroxide, giving me lead 2 sulfate, lead 4 sulfate there, and a water. Here's my trick. This indeed is a double replacement. And remember, for doubles and singles, I like to write water as HOH. It helps me balance. Double replacement said hydrogen went to hydroxide, lead went to sulfate. Hydrogen hydroxide and lead sulfate. I can see the two products coming out by that double displacement. For singles and doubles, I like water as HOH. And here's why. When I tally now, left and right, I'm going to count H's. I'm going to count the polyatomic sulfate as 1 unit. I'll count lead, and I'm going to count the polyatomic ion hydroxide as 1 unit. On the left, there's 2 H's and 1 polyatomic group of SO4, 1 group of SO4 sulfate, 1 lead, 4 hydroxides. Right side, 1 lead, 2 sulfates, 1 hydrogen, 1 hydroxide. HOH for the water. Well, where do you want to start? At the top? 2 H's, 1 H. Let's start by doubling the water. We might end up changing that. I can already see we're going to change it because the OH's are at 4. You want to just go there? I notice right away if I put a 2 over here, I'm going to end up changing it because the OH's are at 4 at the bottom of our tally chart. So I know that's got to be a 4. Repair the T-chart. 4 OH's and 4 H's making the component of water. Now when I repair the hydrogen, I need a 2 on the left side. Repair your T-chart. 2 times 2 is 4 H's and 2 polyatomic ions of sulfate. What's left? 4 H's, check. 2 groups of sulfate, 1 lead, and 4 hydroxides. We did it. The HOH trick. Number 8 says aluminum with HCl, single displacement here. Aluminum kicks out hydrogen, elemental hydrogen, and a new compound called aluminum chloride, a single replacement. If we simply tally, left, right, aluminums, hydrogens, and chlorines. 1 of each on the left, 1 aluminum, 3 chlorines, and 2 hydrogens on the right. Let me move that up for us, sorry. ALs are good, H's and CLs. Well, I notice that HCl is combined over here, and they're separated on the right-hand side. I know whatever I place in front of HCl has got to take care of the H's and CLs together. So what we're looking at is 2 H's and 3 CLs. Both of those turning into a 6 provides me the next number that they can both be divisible by. Let's repair the T-chart and kind of talk through what I said. I have H's and CL's separate on the right, but they're together on the left. if I turn Cl's into a 6 and H's into a 6, I provide a common number in which I can get the HCl to balance over here. Last thing to do, repair the aluminum. 2 Als, 6 H's, and 6 Cl's. 2 aluminums, 6 H's, and 6 Cl's. Home stretch, couple more. Calcium phosphate with hydrogen sulfate gives me calcium sulfate and calcium dihydrogen phosphate taken twice. Interesting. The polyatomic ion phosphate did not stick together. So we got to count individual atoms. Let's see. Left, right, we have calcium. I'm going to leave the phosphate together. I was just kind of deciding, but I do see the phosphate there. Yeah, I'm going to leave it together. I see the hydrogen, and let's leave the sulfate together. Let's see what we got. 3 calciums, 2 groups of the polyatomic phosphate, 2 hydrogens, and 1 polyatomic ion sulfate. On the right, 1 calcium, 1 sulfate, 2 calciums. Separated here, didn't it? Calcium and calcium. And then 1, 2 times 2 is 4 H's. Distributing that 2 gives me 4 H's and still 2 polyatomic ions of the PO4. That 2 is going to distribute through to give me 4 H's and 2 groups of PO4. Well, this looks interesting. Where to begin? Well, one of the things I notice is this calcium's a 3, and I've got it separate over here. I might choose to just ignore it for a minute because it's not going to be helpful. I notice that sulfate is fine. Those are 1s. I'm going to try the hydrogens. I'm just trying to try something. Let's try a 2 here. Let's try it. 2 times 2 is 4 H's. 2 groups of the polyatomic give me 2 sulfates. All right. That says, okay, now let's take care of those sulfates next. I want to try a 2 here. And I'm doing that to repair the SO4s. That gets me to 2 sulfates. But look what it also did. 2 CAs plus 1 more. Oh, that's 3 CAs. Ah, look at that. We did it. 3 CAs, 2 groups of PO4s. H's are working, 2 groups of sulfates. A 1, 2, 2, 1. So I'm glad we left the polyatomics together there. Last one, number 10. H3PO4 with HCl makes PCl5 and some water. This one is not advantageous to break apart HOH, and I say that because I don't see OH as a polyatomic over here. I did in number 7. I see H and OH. That's why I knew to separate it. It helps me count. But I'm not seeing that in number 10, so I'm just going to count them as separate elements. I'm going to go left, right. We're going to count H's. And notice here, I do not see PO4. It didn't stay together, so I got to count P's and O's all separate. H's, P's, and O's. Here's another H and another Cl. So those are the 4 elements we're tallying. H, P, O, and Cl. Now let's count. 1, 2, 3, plus 1 more is 4 H's, 1 P, 4 O's, and a single chlorine. On the right, 1 phosphorus, 5 chlorine, couple of H's, and 1 oxygen. Looking it through. I predict the only place we have an oxygen is here. My gut is telling me, why don't we start with the oxygens so that I place a 4 and get these oxygens. Let's just try it. Let's try a 4 in front of the water and repair the T-chart. 4 O's and 4 times 2 is 8 H's. Alrighty. Now I didn't want to start with H's because they were separate over on this side, and sometimes that's just not helpful if they're separated like that. Alrighty. Now I can kind of predict this guy, HCl, and I'm doing so because the chlorine is in a single spot. If I have 5 chlorines on the right, let's try it. Let's put a 5 on the left and repair the T-chart. 5 chlorines, and then counting, there's 5 H's plus 3 more is 8 H's. 8 hydrogens. 5 and 3 additional is 8. 1 P, 4 O's, and 5 Cl's. We've done it. A+ on the balancing. Good work, gang. You are now ready to ace that test tomorrow.